All right, everybody, welcome to the video here for lesson number 7, solving radical equations. So for this video, we're kind of doing the same thing we did in lesson number 6, where we're going to try and isolate the square root and square both sides of the equation. We're just going to get some problems here that come out to be a little bit more challenging algebraically, all right? But the process of the radical piece of this is the same. So let's just jump into one. So for the first one, I'm going to add x to both sides. So I have the square root of 2x minus 7 is equal to x minus 3. Square both sides, and I have 2x minus 7 is equal to x minus 3 squared. Well, for that, we want to either make our boxes or start to hopefully be able to do these with mental math, however you want to do it. So then I get x squared minus 6x plus 9. All fine and dandy here, but we want to make sure that we solve this. So to solve it, we have to be equal to 0. So I'm going to subtract 2x and add 7. Notice I'm subtracting the 2x and adding the 7 so that the x squared stays positive. I don't care what side the 0 is on, right? All I care about is that I am able to, factor this, right? So then if I factor this, I'm going to get x minus 4 and x minus 4. That's what multiplies to make 16, but adds to make negative 8. So then we have x equals 4 as my answer. Now let's talk about our check. So if I was to check this, I want to be able to graph it. Obviously, I don't have the calculator here on my computer, but I have Desmos, and that's just good enough. I just want to see where they intersect, right? So I want to plug in the square root of 2x minus 7 minus x. So if I go back to Desmos here, the square root of 2x minus 7, so we need a square root here, 2x minus 7, and then minus 3, and, oh no, minus x, and then the minus 3 is the other, minus x, and then minus 3 is the other equation. I can't get this to work. There we go. All right, so we see that they intersect at 4, right? So the x value 4 does have an intersection point, so we are all set there to go. Let's take a look at the next one. So next one, if I subtract 2x to the other side, I have the square root of 4x minus 1 equals negative 2x plus 2. And if I square both sides, I get 4x minus 1 is equal to negative 2x plus 2 squared. Again, I want my little boxes here, right? So I have negative 2x and 2, negative 2x and 2. If you have 2 minus 2x, it's the same exact thing. So this becomes 4x squared. This becomes negative 4x, and just positive 4. So then this becomes 4x minus 1 is equal to 4x squared minus 8x plus 4. So then I can move my terms, right? Again, I want to keep that x squared positive, so subtract 4x and add 1. So I have 0 is equal to 4x squared minus 12x plus 5. And we have the AC method. Yay! So the AC method asks us, well, what multiplies to make 20, but adds to make negative 12? So that's negative 10 and negative 2. So we have 0 is equal to 4x squared. Break apart negative 12 to negative 10x and negative 2x. And then do your grouping method. So I have a 2x, leaving me with 2x minus 5, a negative 1, with a 2x minus 5. So then my two factors of this equation are 2x minus 1 and 2x minus 5. So what are my answers? X equals 1/2 and x equals 5/2. again, I want to check it. So if I go back to my calculator, so I have 2x and 4x minus 1, so I have 2x plus 4x minus 1. And the other equation I have is 2. These two things only intersect once, and it intersects at 0.5. So I know when I'm looking at this 5/2 answer is rejected. It's the extraneous solution. So our only answer is 1/2. Next one. This one's kind of tough. Start by squaring both sides. That's going to give you x plus 4 equals. Now when I square this, it's still a binomial. So I still want to make my boxes. So I have 3 square root of x, 3 and square root of x. So 3 times 3 is 9, 3 square roots of x, and square root of x times square root of x is just x. Just like we did in class, I'm going to put everything that's not a radical first, so x plus 9 plus 6 square roots of x. Move the x and move the 9 to the other side. X's should cancel, that's nice. Negative 5 is equal to 6 square root of x. Divide by 6. Negative 5 over 6 equals the square root of x. Now you could keep going here, but if you're smart, you already know this is not going to check. Why? A square root cannot equal a negative number. I'm saying the square root of something equals negative 5 over 6. Doesn't work for us, right? So even if we were to square both sides, I'm going to get 25 over 36 equals x, but when I graph it, it shouldn't check. So I'm going to have a square root of x plus 4. And I have another equation here of a square root, but it is 3 plus the square root of x. Notice they never touch, right? They never touch, no matter what I do here, right? Cool thing about Desmos, you can just keep zooming out. You'll see they just never touch, right? They're always going to be just next to each other, right? So there's no solution to that equation. The last one in class I said was kind of like a challenge question. So can you come up with a way of solving this, right? A way of solving this. Well, the way of solving this is actually using something we did at the beginning of the chapter and applying it to this lesson. We have to create a common denominator. So to create a common denominator, my common denominator for this problem is going to be the square root of x plus 11. So the number 1 in the middle here, I'm going to rewrite as the square root of x plus 11 over the square root of x plus 11. That's going to give me my common denominator. Once that's done, I just have the equation that's left with the numerators. Because once I have a common denominator, well, guess what? The denominators don't matter anymore. Subtract x to the other side. So I have negative square root of x plus 11 is equal to negative x plus 1. I don't want that negative there, so I'll get rid of it by dividing it. I don't know why I put 7. That should be 1. And I have the square root of x plus 11 is equal to x minus 1. Square both sides. X plus 11 is equal to x minus 1 squared. Well, x minus 1 squared, we could do my boxes and see that it comes out to be that. So again, you're just making your box, right? X minus 1, x minus 1. We've done this a billion times. Move the x, move the 11. Move the x, move the 11, so that we have 0 is equal to x squared minus 3x minus 10, and then look how nice that is. That becomes factorable to x minus 5, and x plus 2 equals 0. So then we have answers of x equals 5 and x equals -2. Again, just like we've been doing this entire lesson and the previous lesson, we have to check this nasty, nasty little equation. So let's graph it. So x over the square root of x plus 11. So I have x divided by the square root of x plus 11. And then that was -1. And the other equation is just 1 divided by the square root of x plus 11. And they intersect at 5. Only at 5. So that means this other answer of -2, well, it doesn't work. Now, here's the deal. This is really just some advice here, right? If this was a multiple choice question, I would never do any of this algebra, to be honest, for any of these. Because eventually you're going to have to graph it anyway to check what the answers are, so you might as well just graph it and see what the answer is right from the get-go, right? The only time I'd ever do the algebra is if I'm requiring you as the person creating your test to do the algebra by making it a part 2, 3, or 4 type question, or saying show algebraically in some way, shape, or form, right? So it's good to know how to check it algebraically and do it algebraically, but also graphically might even be the only way that you need to know it depending on how the question's asked on a test or the Regents exam, etc. All right, so make sure you keep practicing both, especially with these nasty ones, right? That's a lot of crazy algebra you have to do for this question. I would never give that to you as like a part 3 or 4 where you had to show all that work, but I could easily give that to you as a multiple choice, and I would think that that would be an easy multiple choice question because you're just graphing it and seeing where they intersect. All right. Hopefully this video helped. If you're still having trouble with this, come and see me. All right, and enjoy the rest of the weekend.